Welcome to the Epic Melon Podcast, conversations with the real humans behind broadband networks, cybersecurity, and the future of communications. Brought to you by QA Cafe. In this episode, I chat with Jussi Kiviniemi, self-described Wi-Fi janitor and CEO of Hamina Wireless, about the state and future of Wi-Fi networks, how they got to be where they are, and how network planning is key to getting them to work well. Okay. All right. Hi, everybody. Jason Walls here from the Epic Melon Podcast again. I say again, but I'm only on episode 11. So to me, it sounds like a lot, but I realize someday it'll be in the 130s and that joke will get old. I'm here today with Jussi Kiviniemi.
Yes, sir. Yes, sir.
I did it.
Jason.
And so I've actually known Jussi for a couple years, working on some different stuff. He's way cooler than me, and he knows an awful lot about Wi-Fi.
I don't know about that either, man.
It's funny because I was going to put, so obviously, you are the founder and CEO of Hamina, but since I've known you, you've done a great many other things. So I feel like you've sort of transcended that title. I like Wi-Fi janitor is the best, right?
Yeah, I like that too, because that's what it's really about, right?
Right. Cool. So it's Epic Melon is entirely funded by my employers at QA Cafe, but the opinions expressed by any of us on this show, myself or Jussi, are our own opinions and don't represent those of QA Cafe, its ownership, or Hamina Wireless. And since we are entirely funded by QA Cafe, I'd like to give a little speech about our products before we go. And those products are CD Router, CloudShark, and Passport. CD Router is the industry standard test solution for broadband gateways, Wi-Fi routers, and other customer premises equipment. CD Router contains thousands of fully automated test cases designed by network experts covering feature validation, stability, certification, and performance all in one. Moreover, CD Router's world-class support team acts as an extension of your own, helping you understand the technologies and build better products overall. QA Cafe's CloudShark is the way to make network packet captures an easy and useful part of your cybersecurity workflows. CloudShark helps you work through tough issues together without passing around large trace files, losing data, or risking security leaks of valuable information, and helps entry-level analysts learn from your senior experts, curate best practices, and standardize operating procedures around packet captures. Lastly, QA Cafe's Passport is a fully automated test solution for testing the connectivity and interoperability of IoT and smart home devices. Testing with Passport is as simple as connecting your device, selecting tests, and getting clear pass-fail results with full log data and packet captures to find and resolve bugs before they end up as a bad review of your product. To find out more about CD Router, CloudShark, and Passport, visit us at www.qacafe.com. That's my front-loaded advertising services.
There you go.
Yeah. I'll rehearse that a couple times. So the stuff I want to talk about today is obviously, for me personally, right? There's it's not that I find, because I end up dealing with the networking world from a very jack of all trades generalist perspective, right? By necessity, right? Of the things I have to deal with. And what's interesting to me is just how deep the rabbit hole can go when it comes to specialization of a particular topic. And when it comes to 802.11, that there is, it is fascinating to me that as a networking technology, it is entirely its own industry in terms of just sheer conversation, right? Like you can spend your entire life in that space and have a very fulfilling career and never, right? And never have to, never touch any other parts of things. And that's one of the things that I've sort of appreciated about watching you is just how in depth those things have gone and how you've gotten now to the point, with Hamina at least in basically fixing wireless problems, because, and I'm sure we'll talk about this, it's not built for every use case, but it's so ubiquitous that we kind of need it to be, right?
Yep.
So talk a little bit about Hamina, but I want to talk about how it is that you've got to this point.
So where do you want to start? Hamina, how we got there?
I would let's start with what you're doing at Hamina, because it's it's the culmination of all of the stuff behind it. But it's like, as you've seen, a couple other themes of this show is that I feel like most of us in the networking world don't get here on purpose, right?
Mm-hmm.
So
there you go. Yeah. First of all, thank you for having me, Jason. It's good to see you again. About Hamina, we kind of, like you said, Wi-Fi is a victim of its own success, and that's why Wi-Fi is now used everywhere, and from everything from nice to have things, like let's say web browsing, casual web browsing for consumer use, all the way to the most critical of business applications. And it's come to the point where actually most businesses rely on Wi-Fi, if for nothing else, then smooth video conferencing with their customers and partners and stuff like that. But it can be like hospitals, obviously, running their mobile equipment, warehouses, the robots run on Wi-Fi, things like that. Factories run on Wi-Fi, stuff like that. So it's become very, very critical. And so that also means that it needs to work all the time, like pretty flawlessly. But because it is a radio frequency medium, it's a wireless method of transfer, there's a lot of ifs and buts and things like that. There's a lot of things how you can make Wi-Fi. There's 1,000 things how to make Wi-Fi fail.
So one of the things that Matt used to joke about, Matt Langlois, who I work with, right?
Yeah.
Because we used to work together on DSL technology, and he was like, "Look, DSL, or it was like ADSL is robust enough, or DMT, right? Discrete multitone is robust enough that you can run a signal over chicken wire, or like." And he was like, "Which is the worst environment imaginable, except air."
That's well said. That's well said, and exactly right. And when Wi-Fi also, in another way, it's a victim of its own success from technical perspective, because Wi-Fi pretty much always works to some extent. Like it's very resilient for interference and everything, like misconfigurations and everything. So it almost always works to some extent. But then when you start cramming more bits through it, when that critical video conferencing comes, when you introduce more client devices, when latency becomes a critical issue, all of these things, like when they start happening, and that happens more and more in today's world, you run into problems. And the number one cause for Wi-Fi problems in enterprises is the lack or improper design of wireless networks, or the lack of designing wireless networks. And that's why we at Hamina build tools for designing wireless networks. And
right. And I've seen some of your cool like mapping stuff, right? So
exactly, it makes the invisible visible, you could say.
Right. Yeah, and even just looking at that, I'm like, oh, it's like most of us, at least in the home environment, we kind of just half-ass it, right? We're like, I don't know, we're just going to put this where we want.
Yep.
And since I deal with a lot of the service provider space, it's like that's a huge headache for them, because the consumer isn't supposed to know anything about this stuff and doesn't need to know anything about this stuff. But at the end of the day, they're the ones that get blamed for the fact that the network isn't working. So now they're trying to like put their hands all over the home Wi-Fi to make sure that. So absolutely. I mean, I'm sure I have, I'm sure if I were to map my home of what it looks like, it's really terrible.
I don't know. Homes are pretty simple. There's usually 1 or 2 or 3 routers, so there isn't much of interference. There's some coming from your neighbors, depending on where you live. And also, like, just simple things make your home Wi-Fi so much better. If the router is behind the cabinet, just raise it on top of the cabinet. If it doesn't work, just change the channel of the router, and there's a pretty good chance that it works. But then these problems just get amplified and like exponentially worse, and like the number of problems just exponentially increases when you go to 10 access points, 20 access points. A hospital campus can easily have 3,000 access points, something like that,
right.
or 5,000. And universities, or all of that, it's easily a 4-figure number. And that's, you can imagine, like, it's not just Wi-Fi isn't just about coverage, about interference. It's about capacity, airtime, all of that kind of stuff. And that's where you need some kind of visual tools to design not just for coverage, but capacity, everything. And historically, these tools have been there has been tools for now like 20 years. We've kind of started that genre, Wi-Fi planning and site survey tools, back in the day of like like more than 20 years ago in a different company. But then like I feel like before Hamina, these like professional grade wireless design tools have not been easy enough to use. Like they, it's been slow to get started. You need to install like gazillions of gigabytes of stuff on your computer that loads your computer,
Yeah.
and then you need to read a user manual and go to a 4-day course and another course, and then maybe operate the tool sufficiently. But
Right.
we just
Right.
like web browser based sign up for free. In fact, which is new, you can actually design your home Wi-Fi for free with our tool. You can sign up in 1 minute and you can put in your
Oh,
home
I need to
floor
go
plan.
do that.
Yeah, man. And you can design and optimize your home Wi-Fi. You just, put in the main walls or just,
Oh
click up.
man,
Yeah,
my
yeah.
teenager will be very happy.
Well, we should do a video version of this to your blog actually, where we
That's
would
a super good idea, actually.
show a home, like couple of floors, and see how it radiates through the floors or doesn't. How it
Right.
impacts when you take it from behind the cabinet to the ceiling, the router, things like that. But yeah, that's what we do. We are not a home company, but we were like, let's do the home users a favor. This is very new. We haven't promoted this in any way, but you can just go on your web browser, sign up at Hamina in 1 minute and design your home Wi-Fi or improve it.
Cool. Well, that's awesome. I didn't know that, so I'm going to try that out.
Yeah, absolutely. But yeah, that's kind of what you do. Tools for designing better enterprise wireless networks. And if you want
Cool.
to use it for free for homes.
So one of the things that I end up dealing with a lot now, obviously from the operator side, device management and Wi-Fi management, but that's been done from sort of a single vendor perspective by many different vendors for a while now, right?
Mhm.
So like, that's obviously one of the things that Mist does. It's one of the things that Meraki does. It's like these managed, these enterprise Wi-Fi solutions, right?
Yes.
Are counting on the fact that they're managed networks to be able to work better, right? How how well does that work? Or do you still have to like try to make, do you still have to really, really pay attention to this process of making sure everything's in the right spot and everything? Or, you know what I mean? Is there a balance between computers fixing the problem versus still having to go and like make sure that it's actually designed very well?
It's definitely a balance. It would be nice if you could just sprinkle radios here and there and everything would work properly. We'd be doing something else if that was the case. It's not that's not yet the case, but the automated systems that heal themselves a little bit, and they Meraki Mist that you mentioned, and many others, they do a fantastic job at kind of automatically adjusting the transmit powers, the channels of the system. There's
Right.
AI-based troubleshooting tools in a lot of these, and all of that. Automatic packet capture, which then can integrate with Cloud Shark, for example. For example, Mist can automatically take a packet capture when a problem happens, and then feed that off to Cloud Shark on your second browser tab. You just open that in Cloud Shark, and you're off to analyze it. So that kind of stuff, all of that helps, but they don't kind of, overcome the laws of physics. And you still need to be conscious of kind of like how far the signals go, how much the radios are interfering with each other, how much capacity you have left in the network, that kind of stuff. It just needs to be designed based on customer requirements. If you just
Right.
slap them in the ceiling, it's like, you can build a house without a blueprint, right? But I'm not sure it's gonna be a great house and meet the needs of your family and keep them warm and stuff like that. So I
I've tried that with Midjourney AI, and the
Yes.
results are hilarious.
Oh yes, absolutely.
Speaking of which, what software were you guys using when you were making those really? So UC does a lot of webinars, and the ones that you were doing recently, your teaser images were really cool because they were basically your faces, but like AI generated, right?
Yeah, correct. So I just started playing with Midjourney, like when we did before we started our webinar series. I was like, okay, we have a theme for every webinar. How do we get like really nice theme shots? And this one was like, it was called Wi-Fi 6E and 5G. Where did we land? So I was like, this should be pilot theme. So I
It
started
looks
making
so great. It looks so good.
exactly Midjourney is amazing. So I started making like pilot images with crashed airplanes and stuff like that. Not crashed, but like awkwardly landed airplanes. And then Midjourney does have this plugin called Inside Face Swap, where you can swap the faces like that Midjourney creates with faces that you have uploaded. It takes, I don't know, I I got pretty good at it in 1 hour. So that's roughly like 1 hour of trial and error. And then for every image you make, you probably get 20 failed ones or 20 not good ones. But, out of 20, you get one usable image. That's
Right.
what I've seen. But yeah,
Right.
it's pretty amazing. And it's just getting better all the time. You can see it.
So as a segue, with the sort of Wi-Fi area design that you guys are doing, is there anything along those lines that you guys are developing software wise, like, the ability to be like, okay, here's a building, here's our tools for mapping, and then the software is going to sort of figure out where it is that you're supposed to put your APs and stuff like that.
Yep, that's coming. Like automatic planning is coming and stuff like that.
Cool.
Also,
Very
a
cool.
lot of like, machine learning things are on the pipe as well, like where we pretty extensively, nothing like Midjourney, but you use a lot of machine learning to solve like a little bit more complex tasks that
Right.
are, reasonable for a human, but hard for a computer without machine learning.
And I like the way that you put that Wi-Fi is kind of a victim of its own success, because I feel like I I feel like this happens with a lot of different standards, right? Where, I mean, look at TCP, right? It's like when they're designed by people who are either designing for a very specific use case, or rightly so are designing it in sort of a vacuum,
Yeah.
right? Where they don't know how reality is going to hit them in the face later. And it's like Wi-Fi's benefit is the fact that it is Ethernet. And, so it was poised to already work with everything that already existed
Yeah.
from a higher stack layer, the level, right? And uh, and then on top of that, it was just so damn convenient that it's in everything, right? Is it it's the there's a couple of other companies that I've talked to that are working on sort of at the application layer, right? Being like, okay, we know we're going to have to deal with Wi-Fi underneath what's going on, right? We know we're going to have to deal with certain latency.
Mhm.
Uh, is that do you feel like when you're designing it, do you sort of go through and be like, well, what are the most common things that you're going to have to be doing with the network, and then sort of set it up that way?
Yeah, it's what you're gonna do with the network and what kind of devices you're gonna use to access the network. They do impact the
Oh yeah.
requirements of the network, and that's kind of like usually the step one that you do in Hamina.
Okay.
Like
Like what? Like whether or not people are going to be majority like iPhones or something, or is it like,
what like are you first of all, like what's the most common, let's say least capable, most common device that you use to access the network, and that
oh, there you
affects
go.
on a little bit maybe the signal value stuff, or the signal thresholds, things like that. Of course, like which areas you should cover, you can kind of document all of that in the applications, the map and stuff like that before you start the plan. But also like capacity is a really big deal in Wi-Fi these days, especially with like, we all know a lot of devices and a lot of people having video conferencing and all of that. So in our
Hmm.
tool, like you say in this area, I'm actually gonna have, a couple of hundred iPhones, a few hundred
Oh,
Macs,
cool. All right.
and then it will show whether any of the Wi-Fi radios of the access points will be overloaded, and things of that nature.
Oh, cool.
Uh,
Cool.
Really quickly going back, sorry, I'm a slow guy, so I'm rewinding back to what you said about the Wi-Fi vendors, the Mists, the Merakis, and kind of how they relate to these kind of tools. So they're very complementary, because Mists and Juniper's, Merakis, everybody, Cisco's, their beef is in the infrastructure and like what we talked about, like AI-based troubleshooting,
Right.
centralized configuration, optimization, automatic optimization, all of that. That keeps them busy. So it leaves us a room as tools vendors to provide tools around that. And what we actually figured is, because nobody had really done design tools that deeply integrate with these systems, but the Junipers, the Merakis, they have excellent Arubas. They have excellent APIs that you can tap into. So we did
Oh, okay,
like,
okay.
you design a network, you in Hamina, you click a button and it automatically starts a new site in Juniper. It fires up, creates the site, puts the access points into the site from
Oh,
the
cool.
inventory. It
Okay.
automatically commissions the maps, places the access points on the map. Like it starts the entire site directly from Hamina. Just, we just make like 50 calls to the APIs behind the scenes when the user clicks start the site, and there you go. So that kind of automation is possible. And the other way around too, like you click a button in Hamina and we suck in the current network situation and we overlay, instead of the plan, we now overlay like the current situation of the currently running network and
Oh, that's
overlay.
cool. It's like, this is what you intended and this is the reality.
Exactly. And it's like these systems, like the Wi-Fi vendor systems are so good and the APIs are so comprehensive. There's, sky's the limits.
That's really cool. That's really cool.
It's kind of
And so
like what
it's like,
we did with the integration back in the day between Cloud Shark and Juniper Mist, right?
right,
That was kind of similar things like third-party vendor of tools integrating with the Wi-Fi.
right. And a lot of those vendors are doing that, like to the point where like some of them have made their own, they're not really app stores, but they're basically like, here's a list of integrations, you know, and we'll help you to a degree, but here's all the things that work with it, that
Exactly.
that our open API now allows, which to me is always, we wrestle with it at QA Cafe about, it's like, do we want the headache of having to manage the relationships between a whole bunch of third-party vendors or not?
Yeah. It's a balancing
Yeah,
act, isn't it? And
yeah,
for us, it was like in the beginning, we were nothing, right? And then there's these big vendors. So we were like, we will not make our own API first. We will just tap into the vendor APIs and accomplish the tasks that way so that the vendors don't need to do anything for us. We can just, put, query against their APIs and that's,
right.
we don't
Yeah,
need to do
yeah.
our
It's
own.
easier to be on that end.
It really is.
So all right. So why Wi-Fi? How did you get to this point?
Oh, geez. I studied, well, I got my first computer when I was like 4 years old, thanks to my parents who were kind of very, very future, like forward looking in, like, because this was in 1924, and I'm an old guy. And you know, then like I fell in love instantly with that stuff and then the internet and went to the university and I studied actually with information technology, but that was mostly coding. And quite quickly
Yeah,
I realized these guys are a lot faster at this, a lot smarter at coding. I need to do something else. So I actually pivoted to industrial engineering and management and I just did a minor in like
oh,
information
interesting.
technology.
All right.
So
Yeah. No,
I was
that's like,
I was this half business, half technology guy, but then I
yeah,
ended up as a researcher still at the telecommunications laboratory of the university. And in there, I was also the kind of half business, half tech guy. So I was doing
that's really
coding.
funny. That's actually the background of most of us here, because we had the UNH interoperability laboratory that most of us here at QA Cafe have worked at, right?
There you go.
So
There you go.
there's
So
so
you know
many
it.
of us that were not in a technical field that
Yep,
worked there that ended up
exactly.
getting into networking only because of that, right?
Precisely. But this was the University of Technology, and I was working at the telecommunications laboratory as a
Right.
researcher. But still, I was like a half business guy. So I was this oddball guy, doing a little bit of coding, a little bit of like thinking about business models of these research projects, stuff like that. And then at when I was graduating, like when I had pretty much done my master's, I saw a job ad at Ekahau, which was a location tracking company back in the day. But then very quickly when I joined Ekahau, we also span off like you could say the world's first like visual site survey product for Wi-Fi through an accident. And then
Oh,
I ended up like heading that business unit, the spin-off business unit, which then eventually became all of Ekahau, and then was sold. Like Ekahau divested our location tracking business at some point. Then all we had was the Wi-Fi design tool, and then that was sold to the States a little bit later. but a lot later.
Right,
But,
right, right.
but so that's how. Long story short, after that, I wasn't supposed to go anywhere. I went to see the CEO and CTO of Juniper Mist, Sujai and Sujai Hajela and Bob Friday, and they were like, "Jussi, this isn't a casual coffee. This is you coming to work with us." And I was like, "Whatever." No. How do you say no to those guys?
It's,
I,
it's like you
I
could have warned me. It's probably better they didn't, though, right?
exactly. And then I was there for a couple of years, which is exactly what Bob Friday predicted. He was like, "Do not start your own startup yet, Jussi. You want to learn AI and enterprise networking with Mist first, so that you're better off starting your own startup after you have learned more about enterprise networking and AI." Granted, he was very much right. Usually is, and then I started Hamina. That's kind of a
Right.
long story short. And now it's like 20 of us in here, like, out of which 18 are making product, and then we have one guy in sales, one person in market.
I understand that feeling.
Kind of long story short. That's a long
It's
monologue. Sorry about that.
It's like all being in perpetual startup mode, right?
Yes, sir.
So when it comes to when it comes to the stuff you are doing now, just like I've noticed a couple of different use cases from things that you've posted. So like obviously there's there's like an enterprise campus or like a hospital kind of situation, but also like stadiums and stuff
Yeah.
like that. Like what are some of the like biggest differences in use cases that you kind of see, like in how the wireless network is supposed to be set up and what people end up expecting versus what they get?
Well, that's a really, really good question. So you couldn't have picked like two more different examples actually, and
Yeah.
diverse examples than a stadium and a hospital. But so our tool is used like everywhere. The leading auto manufacturers are using it, and then there's hospitals, and then there's people who build stadium Wi-Fi and stuff like that, and then there's outdoor Wi-Fi and everything in mesh, everything in between. But oil refineries. But I would say like a hospital, kind of the expectation is critical communications. It needs to work all the time, 100%, like low latency stuff like that. But luckily, it's doable in a hospital because you have walls and things like that. And walls are actually good. They kind of, Wi-Fi access points don't overlap with one another so much when you have
Right.
walls. And it's
Right.
today, it's not like in well-designed enterprise environments, you put enough access points so that you have enough signal. It's more like, do they interfere with one another, and do you have enough capacity? That's more the question. But yeah,
Right.
hospital networks are very carefully designed for those critical communications, whereas stadiums are a totally different animal. No walls whatsoever, right? So the access points, you put an access point the other end of the Dallas Cowboys Stadium, and in the exact other end with your freaking Galaxy S2 ancient phone, you can clearly pick up the signals on an empty stadium from that, access point on the very other end of that stadium. So that means, sure, there's coverage everywhere. You put one access point in the middle of a stadium, like in the bowl, it covers the entire stadium coverage-wise. Not
Right.
great coverage, but it does. But then when you need to serve 30,000, 50,000 people, that one access point isn't going to cut it, right? But then when you start placing these access points, you run out of free channels in Wi-Fi, like uninterfering channels, because soon you have filled all the channels. You put 25 access points and you have all the 5 gigahertz channels filled up,
Right.
even 20 megahertz, right? Where do you put the next access point? Which channel do you put the next access point to? They're going to be interfering with one another. So you need to get creative and put access points, either heavily directional antennas from, shooting from the top. Maybe you put access points. Often you actually use also under seat. So the seats.
I was just going to say that. Is it like an Oprah situation where it's like, everybody look under your seats, you have an access point.
Get an access point. Precisely right. But this is a very common stadium design methodology is, placing access points under the seats.
Interesting.
So
I wouldn't have thought that.
Actually, it contains the signal so well, not on an empty stadium, but you start packing it with people, and the people actually attenuate the signal so much that it makes a great experience.
Or bags of water.
Yeah, exactly. We are. That's what we are.
So I was going to ask, specifically sort of so about the stadium use case. The one thing I always sort of, I don't know. Remember, I was talking at the beginning of the show about how it's fascinating to me that there are some technologies that are so there's enough to them that you could occupy yourself with them indefinitely, right? But then
Mhm.
you have, you know, the rest of the world that might be another technology that also has an entire industry built around it with people who are embedded in it and know the most about what they're talking about and think that it is the greatest thing since sliced bread. And
Mhm.
so you have people in tech media who try to write clickbait articles like, which is going to win, Wi-Fi or 5G? And I'm like, that's such a dumb question. Like, but do you end up having to deal with that situation in certain deployments where it's like the expectation is that the users are going to be on the mobile network anyway? So like, well,
Yeah, yeah, yeah. So I think I've even hosted a couple of Wi-Fi versus 5G type of webinars with panelists and stuff. But yeah, it's of course like, and I can see where it comes from, right? It's both are wireless mediums, both are especially marketed as high capacity, high speed, or all of that. Why do you even need both? Shouldn't one win over the other? But we don't really think about it that way. But to me, like public, if you look at public networks today, 5G is just public 5G is just 4G plus. It will
yeah.
evolve to be a little bit better than
Oh yeah.
4G and a little bit
Yeah.
faster and stuff like that. It's in Finland. It's not like, yeah, 5G. Sure, you have it, but why pay for it? Because 4G is like excellent, and 5G can be debated whether it's better in some areas or not even. But so for public networks, it's an evolution. Uh, the
Yeah.
big deal, I think, is private 4G and private 5G, which is marketed as
Oh, right, right, right. Yeah.
so, which is kind of like Wi-Fi in a sense that enterprises can get their own 5G network, and but and then the like some marketed it as, yeah, you don't really need Wi-Fi anymore. You just put 5G access points and that's it, and you put less of them. But that's not really the case either. It's gonna be a nice combination of both. Usually, you pretty much always have Wi-Fi in your network. Then you might use 5G for these very, very critical applications, for example, which
Right.
demand this like guaranteed delivery of packets, things like that. Or if it's another type of requirement, maybe you need plenty of outdoor coverage and you are in a country that supports low frequency private 5G, stuff like that.
Oh,
So
right, 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 right.
further
Yeah.
than Wi-Fi. And in
That's
general,
true. You do have to deal with I imagine it varies greatly from country to country based on their own
Absolutely,
radio
and
regulations.
by
Yeah.
nature, private 5G, for example, private 4G, they just travel greater distances even, or like they are more, in a way, it's a more sensitive setup, so you need less radios per square mile, stuff like that. So it definitely has its benefits,
Right.
while Wi-Fi is still unbeatable for client device support. Your MacBook doesn't support 5G. Your smart TV doesn't support 5G.
Right.
Also, Wi-Fi, people don't speak about this, but capacity-wise, like you look at Wi-Fi has even just 5 gigahertz alone has so much capacity on Wi-Fi compared to like private 5G.
Right. Right. Right.
Even
Right.
if you get all the channels available from CBRS,
Right.
you're not gonna. But even if you did, it's nowhere near Wi-Fi's capacity.
And that's interesting that you bring up the interoperability point because I feel like that is yet another example of how it's the Wi-Fi is a victim of its own success because it's like the
Yeah,
reason it is so ubiquitous is because people did that work early on. From the chipsets and the SoC guys like really early on, making 802.11 extremely interoperable between solutions. And so
absolutely.
that's why it is in everything.
Exactly. It's backwards compatible. And I think Intel did a huge work when they launched Centrino, which kind of combined, the CPU and the Wi-Fi into one package. At least that's how it was
Oh
marketed.
yeah.
So every laptop, in a way, was Centrino capable, and then every laptop thus had Wi-Fi as well. And that's when it exploded. No more PC cards to connect to laptops, no more USB dongles to connect.
Right. And I also noticed that you brought up a couple times that, you keep mentioning video conferencing as the thing that is now pushing things to be a little different. And I've talked before. I don't know if you ever met the company Domos. They're really cool guys. They primarily work with broadband ISPs on optimizing. They're basically they build themselves as a latency management solution,
Mm-hmm.
right? So they have all kinds of crazy math around getting it so that your latency is consistent, because that's what most of the applications need. They need what they hate is jitter, right? If you
Yep.
have consistent, predictable latency, then you'll have an okay experience, right?
Yep.
So, like, do you is it is video conferencing really the one that has been stressing Wi-Fi the most, do you think, because it has those really, really specific sort of low latency, high capacity requirements in ways that we didn't really predict before?
Well, video conferencing is the layman example that works because it uses a reasonable amount of bandwidth and it's reasonably latency sensitive, and we've all experienced like cutoffs and things like that. But there's plenty of others as well. One of them worth maybe mentioning is high definition security cameras. 'Cause,
Okay, yeah,
like often those are also wireless. It's hard to security cameras need to be put into certain places, and do you have an Ethernet jack nearby? Maybe you don't. So they're wireless, and there's constantly streaming somewhere where it's usually stored. All of that 4K or even 8K
oh yeah,
signal. So that's a lot of data. You multiply that by the number of security cameras, stuff like that. So that would be another. It's not latency sensitive, but it's still very, very heavy capacity wise.
right.
And then latency wise, like autonomous robots would be one that's very you need guaranteed packet delivery. You need decent latency, all of that kind of stuff. There's different kinds of examples, I'd say, but then there's these crazy examples that let's make something up to sell 5G, like autonomous cars will rely on 1 millisecond 5G connectivity. Why would you ever build a car that relies on that? Like most of the processing is up locally.
Right.
It's not like you're sending all of the video from all the sensor data into cloud, which would crunch the numbers and then send something back to the car. Like that would be
Right.
doesn't make any sense. They don't rely on any.
It's interesting you bring that up, because from a use case perspective, and from like the what the market is ready for, you'll notice there's kind of a similar rise and fall with streaming gaming, right?
Mm-hmm. Mm-hmm.
Because the whole idea was, oh, okay, our networks are good enough now that we can do all the graphics processing, in the cloud, and literally send you the whole game over your
Yep.
network connection and have you play in real time. And it turns out people really like having consoles that like it hasn't really taken off. And I think, what was it? Google already stopped trying to do Stadia.
Yeah,
Right.
yeah. That's really, really interesting. And I'd be curious. I'm not a gaming expert anymore, but I don't know if it was a technical problem or it just wasn't marketed properly, or if the games were not good enough, if they didn't get the right branch of games. But yeah, I think it's a fantastic idea. That's how it should go. Nobody
Right.
nobody should have a box that generates boatload of heat in their in their living room. But turns out that's still the way to go. That's still the best way to go. I don't know what the fundamental reasons are, but
Well, no, but I really want, so I'm thinking about the car example, right? It's like a lot of these things are based on it's like you can't take the people out of the system, right? So you're right. No, I don't want to have a car that relies that my safety is reliant upon the fact of whether or not the packets arrive on time. I
Yeah.
don't want that, right?
Exactly right. And this is kind of the same thing, like having a game stream out of the internet, incredibly latency sensitive. I don't even know
Yeah.
how possible.
Right. And it's like, I'm sure that it could work eventually, but for right now, it really seems like, from a what people are used to perspective, that's going to be kind of a hard sell. Now, is
Uh,
there anything about is there anything about like the future Wi-Fi versions that are going to solve some of these problems? Because and then again, I hate it because it's like every single time, the WFA and the IEEE are like, oh, we're going to do the next version of Wi-Fi. It's like you can't stop hearing about it, even way before it's even ready for anything. Right?
That's the thing, and that's why I'm a big fan of um, what's already out there. And this is like in 20 years, this is the most exciting time of Wi-Fi, I think, that we're living right now as 6 gigahertz Wi-Fi. So Wi-Fi 6E, Wi-Fi 7
Right.
is big marketing push, which is correct. Like it's the right thing to do that, Wi-Fi also takes like more stance on the marketing. 5G, excellent marketing, stuff like that. Wi-Fi 6E, the layman hasn't even heard of Wi-Fi 6E and cannot say what's different between Wi-Fi 6 and Wi-Fi 6E. Essentially, Wi-Fi
Right.
6E brings the humongous, well, it's obvious to you, but it brings the humongous 6 gigahertz frequency band for Wi-Fi, which means like whether you're using 6E or 7 or, the iterations after, this will
From here
mean
on
that
out. Yeah. Okay. Yeah.
yeah, the modern client devices will be able to use an previously unused frequency band for Wi-Fi, which gives a boatload of capacity, a clean spectrum at this point, so it gives much, much lower latency. And for the legacy devices that still operate on the 2.4 and 5 gigahertz bands, which are kind of the legacy bands of Wi-Fi, the situation also for those guys improves as most of the devices start
Oh,
gravitating
right.
towards
Yeah.
6 gigahertz. And this is, for example, what you can do with our software. You can kind of run a timeline of like, okay, now you have this many client devices on 6 gigahertz only. But as the next iPhone comes out that probably supports 6 gigahertz and stuff like that, this is how you start kind of seeing the legacy bands free up and 6 gigahertz bands starting to fill up more and more, which is a good thing. So you want to find a balance between all the bands. So that's the big deal for Wi-Fi. Really, you can't beat. It's like you're from States or Canada.
We're in the States. We're in New Hampshire. Yeah.
Exactly.
Yeah.
So nothing replaces cubic inches. I think is what V8 guys like to say and stuff like that. I don't know if you're a car guy, but nothing replaces cubic inches. With Wi-Fi, it's kind of like nothing replaces like the amount of spectrum you have available.
Right.
For example, 2.4 gigahertz has 320 megahertz channels available. That's, let's say, 60 megahertz. CBRS, the private 5G in the States, has 150 megahertz maximum, out of which you get, some dozens of megahertz. And then 5 gigahertz has 25 20 megahertz channels, which is incredibly much. And then Wi-Fi 6E, the 6 gigahertz Wi-Fi has more than double, that of 5 gigahertz. So it's an incredible addition. That's in the States and in some other countries, but it's an incredible addition that we're getting right now. It's an incredible,
and that helps all aspects of
all aspects,
yeah.
not just capacity, latency, packet loss, everything.
Right.
As long as you have your client device needs to support 6 gigahertz, and the latest MacBook Pros do, the latest iPad Pros do. The iPhone does not. I believe most of the iPads still do not. Some of the higher end Windows laptops do. Most of them don't. None of the smart TVs do. That kind of stuff.
Right. Yeah. No, and I mean it's good. It's good. I'm glad that and that happened, a lot of it because of some deregulation, right? Like it was the regulators were like, okay, you can finally use 6 gigahertz now. And everybody was like, because I remember you actually had some people that jumped on it for sort of proprietary wireless solutions, right? Like point to point stuff. Like everybody was super excited that they could finally use the band. But then obviously the IEEE was like, okay, now we're going to use it and standardize.
Yeah. IEEE handles the standardizing, and FCC, all of those guys, they kind of free up the frequencies. And there was a lot of advocating done by people in Wi-Fi, for example.
Oh yeah,
Chuck Lukaszewski and those guys. They traveled around the world lobbying for 6 gigahertz frequency to be freed up. And in the States, all of 6 gigahertz was freed up for Wi-Fi with certain restrictions. So, for example, today you cannot put 6 gigahertz outdoors. and you're pretty limited on the transmit powers. Many people don't
Oh,
know that, but you're not allowed. It's what we call low power indoor. LPI is allowed today, what's called standard power is coming up, but that will come with regulation. So you need to
right.
you need to have a set connect all the access points. You need to connect to a centralized server called AF or whatever AFC server, and it gets informed which channels you can use and what kind of transmit power you can use based on the geographical locations, so you don't interfere with the satellites and satellite links and
Oh, okay,
stuff like
okay.
that. So
Do they have like a roadmap for changing that in the future, or is that basically like, well, now that's where this is going to be the case for quite a long time?
it's going to be the case for quite a long time. That's the only way outdoor 6 GHz is allowed to play ball, is through this automatic frequency
Interesting.
coordination.
Huh. That's interesting. That actually puts a lot of things in context.
Yeah, that's why you don't, in outdoor stadiums, you do not see 6 GHz, although that's ironically where it would be needed the most, but you will soon.
Right, because it's the number of channels that would help
Yep.
the problem the most, right?
Absolutely. But that's going to change soon.
One of the other anecdotes I always think of when it comes to Wi-Fi deployments is sort of the differences in building materials from country to country, right? So I end up dealing with a lot of the wired technologies that are used to sort of complement existing buildings, right? So power line and HPNA and all those things. And my favorite anecdote is from a friend of mine from the Netherlands who was like, it's totally different because in the States, all your houses are made out of wood, and are huge. Whereas over here, we have apartment buildings that are literally, the walls are Faraday cages, right? Because they're made of concrete with mesh in them. So they can't get Wi-Fi to go even to somebody's, like, different rooms of somebody's apartment, and they have to rely sort of on the wired
Absolutely.
side.
Like noise insulation, all of that stuff, choice of materials, and also like energy efficiency in modern buildings. Like the more energy efficient your windows are, the less goes through. That's
Oh,
true
yeah.
for cold, but that's also true for Wi-Fi.
It's all radiation.
Yep. Absolutely. And like it also goes to mobile, like public mobile networks, especially in Finland. For some reason, the Finnish network engineers, the Nokia guys, right? Or the we come from Nokia land. Not that Nokia is the networks here, but the Finnish telecom operators. There's at least I heard this story that Finnish telecom operators traditionally have like deployed networks outdoors and then shut them into the buildings from the outdoor, which is at least for Wi-Fi people, it's completely bollocks and counterintuitive, but it's worked before energy efficient buildings. And I think it was Dean Bubbly. I don't know if you know the futurist Dean Bubbly, but he was like, yeah, when I talk to the Finnish engineers, radio engineers, they always say, outside in, always wins. That was his Finnish accent. So from outside.
I like you trying to do a Finnish accent in a Finnish accent.
Exactly. You shoot from outside in, outside in, always wins. If you want to learn Finnish accent, by the way, just watch either rally driving or Formula One, and then you.
Oh, okay.
That's a good Finnish accent lesson for you. Just listen to the rally car drivers or the Formula One drivers.
No, I'm kind of a language nerd, and Finnish has always fascinated me because it is the anomaly, right? It is not part of the Indo-European tree, and nobody really knows where it came from. So I'm convinced it's either fairies or aliens or something. You're like,
I'd go for the latter.
It's like, we're gonna stop here.
Exactly. This meeting is over. What was I gonna say? Yeah, Finnish is weird. Like it's so different from anything else, and it's so hard to like learn perfectly after your like past your teens and stuff. I believe it was Well, in a few movies, for example, Charlie's Angels, the modern 90s version, they used Finnish as their code language when they were
Oh,
talking,
really?
and they wanted to keep it secret.
That's funny. Of course, everybody in Finland watching the movie is like,
Yeah, that's not really how you say it, but yeah, because we're
Cool.
nerds. That's not how it goes. Thank you for using our
Yeah.
language, but let me correct you there, Mr. Ron.
See, but that's the stuff I appreciate. That's actually why I didn't go down the route of being a linguist, actually, is because it was like, even to master one other language, which is always impresses me, anybody who speaks English as their second language, like it's not something that I have ever hoped to accomplish. Was, it's like I have people who are like just writing standards in English, right? And I'm like,
Yep.
there's no way I could do that in any other language, But like,
Unless
it's
you were exposed to that language all your life, right?
well,
'Cause,
no, then that's what I tell people because they're like, oh, why doesn't the U.S. speak any different languages? And I'm like, well, if Massachusetts and Maine spoke different languages from me, then I would probably know those languages.
precisely, but you just don't have to.
Yeah, it's true. All right, Jussi, thank you very much for coming on. I was really excited to have you on, actually. So
Thank you so much, Jason. I really appreciate the invite, and yeah, it's always a pleasure seeing you. We should see more
yeah,
often, man.
no, absolutely, absolutely. Anytime you want to chat, I'm here.
Sounds good to
uh,
me. Good to me.
So I'll end the show the usual ways that I do. If you really enjoyed this, subscribe to us on YouTube because that always helps. I
Great
always
stuff,
say the
man.
usual spiel, but hit that like button, comment on it. All of these things matter to the new social media world, and give us the bumps. If you're listening, subscribe to us on the podcast platforms. So you get those automatic downloads. You never have to push any buttons. You'll just always get it delivered to you, which is very nice. And above all, own the nerdy things that you love and have fun doing them.
That's well said, my friend. That's well said.